The recording has started. So let's start, colleagues. Good morning, colleagues. I guess today's last week Friday we stopped when we have to do this part of the composition of linear transformation, where we let our map T, that n dimension to that m dimension, and also you have that one of, you are having two maps there. And we're talking about how you multiply the two matrices. We remember that when you multiply two matrices, you only multiply two matrices if the number of column of the first matrix is equal to the number of rows of the second matrix. So we had this information. Then later on, we had this map, the product or the composition of two maps, and where you have this TNS. Then now, let's see. There is this information that we usually, okay. Let's take this example under that, colleagues. Now you are going to have two maps here. You have example under that where you have two maps. I guess you see my screen, colleagues. Do you see my screen, colleagues?
Yes, sir.
Colleagues, it's like you are tired. What's wrong? Beside Besh, is there anything? The first map defined by the third dimension XYZ, which is equals to the two dimension of 2x minus y plus 3z, and you have minus y plus 2z. And then again, we have another map. Let me change the color for another map. We have our S. Now the S is taking everything from 2 dimension to 2 dimension. And that S defined by, the S is defined by S of x and y will be equals to 3x plus y, comma negative x plus y, close the bracket. So from here, the question says we must determine, colleagues, you have seen this thing before or what, colleagues? Let me hear from you. Have you ever met this example before? Determine the TS. Determine the TS. And also, you must check the composition of ST if they exist. If they exist, and determine the corresponding matrix. Matrix representation. Colleagues, are you there? Do you see the example?
Yes, sir.
Yes, sir.
So the very same things that was happening when you have to check if you can multiply two matrices is going to happen here. So let's see. In order to answer this, remember you have map number 1, solution. Map 1 or transformation number 1 is this one of T of R 3 dimension takes everything to this 2 dimension. And also you have this one of S that takes 2 dimension to this 2 dimension. Is it clear, colleagues? So in order to check the composition of this, we must check for the product of T and S to exist. You must check, we check what? We check the dimension. We check the dimension of the codomain. The dimension of codomain. Do you understand, colleagues? Codomain of map S. And the codomain of that one, which is what? Which is R2. Do you all agree with that?
Yes, sir.
Yes.
And then you check it together with the dimension. You compare it with the dimension of the domain of T. And the domain of T is what, colleagues? The domain of T is what? Please check, you have the map there. The domain of transformation T is what?
R3.
And it's R3. Ne? So if it's R3, can you please agree that these two you cannot do what? You cannot multiply them because the dimensions are not equal. I told you last week Friday that is the same as matrices. Can I get yes that this one of TS is not possible? Since the dimensions are not equal, you cannot multiply the two, or you cannot dot the two. Can I get yes from you? And you already
Yes.
know that you said that one, okay, fine. You said this one, 2 is not equals to 3. So the product of T and S does not exist. Are you there, colleagues?
Yes, sir.
So if you check that the TS does not exist, let's check the other one. Remember the question said you must check 2 there. The question said determine the TS and ST if they exist. You already seen that TS does not exist, then now let's check our ST. So For ST, the product of ST to exist, we are going to do the very same way. We must check the dimension. We must check the dimension of codomain of T, which is the codomain of T is 2-dimension, and the domain of S. The domain of S is what, colleagues? The domain of S is what, colleagues?
It's 2.
2.
Very good. So we agree that our dimension from T is this, and the dimension from S is this. So we agree that 2 is equals to 2. So our product of S and T exists. Then if exists, then we can carry on. So if that one exists, you and me, we agreed about the matrices. Do you see that? Who can tell your S and T, the new map will be what? R will take everything to this R. Let's start with the domain. The power of the domain will be what? Jesus. Let's start. If I have a matrix A of n by n, and I have a matrix B of n by p, can we multiply? Can we get AB? AB. Is it possible to get AB?
Yes.
Since these two things are equal, since the number of columns of A is equal to this. So what is going to be the dimension of this AB? Is it not going to be M multiplied by P? Or I can write it as M by P. Same applies here. What is going to be the product of this? You are going to have 3 and then 2. Are you still there, colleagues? Do you understand? SMTH012. You have done this, the multiplication of matrices. Then now you are multiplying 2 maps. So we are using the very same procedure. So now, after we have this map, let's see what is going to happen here. We are going to come up with this vector. Let's say you have a vector V, which is equals to X, Y, and then Z. For that 3 dimension, that is coming from that 3 dimension. So you and me, we agreed last week that if I have the product of S and T of this V, vector V, our answer will be S of T of this vector V. Can I get yes from you, colleagues? We agreed about this last week. Can I get yes? Colleagues, are you with us?
Yes, sir. Yes, sir. Yes, sir.
Yes. Then now, This thing will be the same as our S into your transformation T. Your V is what? Your V is X, Y, and then Z. Close them. Then now you apply. Remember when you start this question, they gave us a map of T and they defined that map of T with something. Do you still remember that? So they said the map of T of X, Y, Z is equal to what? Please go up. Is equal to what? Check.
2x
The
minus
transformation
y.
X, Y, Z is taking everything to 2 dimensions. And that's where you get what? You are going to get your 2x minus y plus 3z, comma, minus y plus 2z. Do you still remember this, colleagues? If you want, I can go up. You did not copy. Do you agree with this? No one will
Yes.
ask me where is 2x minus
Yes,
y
sir.
plus 3z and minus y
Yes.
plus 2z come from. All of you
Mm.
understand where this one come from?
Yes, it
Yes,
was
sir.
defined above.
Very good. Now they also defined S. Remember, the S has been defined in 2 dimensions. Do you still remember that S is defined in S is R2, take R2 to R2. So now you have 2 things here in R2. Can you please apply that? When you apply the transformation, when you apply that map of S, what is going to happen? The whole of this will behave as X, and the whole of this will behave as Y. Can you please tell me what is going to be your answer then? Did you copy that map of S, colleagues, or should I go up and you want to copy? Yeah, you
Yes.
see that I'm alone now. The map of S, I wrote that S with a different color. Do you see that S? Please write it down. You have that map S that take R2 to R2 defined by S of X and Y will equals to 3 multiplied by the first element plus Y minus multiply the first element plus Y. Are we all together, colleagues? Can you write that S now here? Can we apply that here? Who can tell? The first bracket will be what?
I think it's going to be 3 into 2x minus y plus 3z
Very
plus
good.
y. You
We are
the y
saying
part
is
here
3 into 2x
two,
minus y plus 3z. After
yeah,
that,
close
you have
to.
what, say?
Then it's going to be, what's the other part? Plus, and then open
It's
bracket
supposed to be
negative
plus y,
y.
but our y is now represented by this. Then you write this inside the bracket s minus y plus 2z. You close this. This is the first element. Very good, brah. Then what about the second element of this?
It's going to be negative into 2x minus y plus 3z, close bracket.
2x minus y plus 3z, close bracket, and then
plus,
what?
Plus open bracket.
Plus, open bracket.
Negative y plus 2z.
Plus 2z. And now I close the other bracket. The other colleagues, where are you? Do you understand what's happening here?
Yes, sir. We are there.
Yes, we understand.
Yeah, we are following.
So now we can multiply, we can remove the brackets inside this. When you remove the bracket inside this, you are going to have open bracket. let's multiply. Let's use BODMAS there. You are going to have your 6x, your minus 3y, and then plus 9z. Is it correct? Then minus y plus 2z. Do you all agree with this? You can use a calculator if you want there. The second one, I see minus 2x plus y minus 3z minus y plus 2z. Then we close the bracket. Can I get yes, colleagues, if everything is fine?
Yes, everything
Yes,
is
sir.
fine.
On the red part, do you have the like terms?
Yes.
I hear there is some, I don't know whether it's messaging or is there any messages at the back or what. Class lab, please take over there. So on the red part, colleagues, element number 1 of this, do you have any like terms?
Yes.
It's what and
Yes.
what, ma'am?
Yes, sir.
What is it, colleagues?
Minus
6x minus 4y plus 11z. Do you agree?
yes, sir.
Yes.
Yes, sir.
On the second element, what do you have?
We have
Minus 2x.
x plus z. Minus z.
Then do you see that y and y, you are going to get 0?
Yes.
And minus 3z plus 2z, you are going to left with minus z here.
Minus z.
Is it fine, colleagues? Remember, our main present this in a matrix form. So now, since you have this, the matrix representation of this, the matrix representation you have on the matrix representation, you are going to use the standard basis. Colleagues, are we together? We are going to use the standard basis, right?
Yes, sir.
Hello? Colleagues, do you hear me? Are you still there? Or maybe I'm
Yes.
offline, colleagues. I don't know.
Yes, sir.
Please talk to me.
We
It's
can
the
hear you.
network. We can hear you.
Do you hear me?
Yes, we can hear you.
Hello?
We can hear you, sir. It's your
We can
network.
hear you, sir.
Can hear you, sir.
My network is poor, or is it your side, colleagues?
It's your side, sir. But we can hear you.
Hello?
Hello, sir.
It's your network, sir.
Hello, colleagues. Do you hear me?
Yes, sir, we hear you.
Colleagues? Colleagues, do you
Say, we can hear you.
hear me, colleagues?
Yes, sir.
Hello?
Yes, sir, we can hear you. You're audible.
All right. I was disconnected due to network, colleagues, so I'm back. I'm back. Let's just hope that everything will go well. Yes. Hello? Hello? Colleagues?
Oh, sir, we can hear you.
Hello, sir.
Yeah, but you must
Yeah.
say that. So thank you very much. I'm back in full force now. Let's see. After you got this product of this ST, then now you must come up with the matrix representation. Last time, the last example that we did on Friday, we said if you don't have, they did not give you the standard basis, then you can use the standard basis here, where we can say the S multiplied by this T of this, the first one is E1. I don't know, maybe this E1, we can represent it as a vector. Maybe let's put a bar on top. And where you are going to have what? You'll have the S of this T. Then you all know that this E1 is going to be in 3 dimensions, since our new map, the new map that we discovered is this one, colleagues. So those things of us, the E1, E2, E3, they will take the dimension of the first of the domain. Then you are going to have your 1, 0, and then 0. Are we together, colleagues? And we know that immediately we see this, we know from the scale that this is going to be S of T of this 1, 0, and then 0, and then this. Can we have this, colleagues? Do you agree? Do you agree, colleagues?
Yes, sir.
Yes, sir.
So from this, you are going to use the answer that we got above them. Or even if you don't do like that, we can still say this one, colleagues, like that. We use this, what we got here. I guess you understand. Can you please substitute the value of x, y, z by this 1 0 0. What is going to be our answer? What is going to be our answer here, colleagues? 6x minus 4y plus 11z and minus 2x minus z. Replace the value of x is 1, the value of y is 0, the value of z is 0. So what are you going to have there? Or should I write everything? 6 into 1 minus 4 into 0 plus 11 into 0. The first element. The second one is minus 2 into 1 and then minus into this 0. Then we close this. Do you all agree?
Yes.
Then when you add these things, you will end up having 6n minus 2. Is it fine, colleagues?
Yes, sir.
On the very
Yes.
let's check the product of this for E2. On the E2, you have S of this T. The product of this, the E2 is 1 0. Please use that the defined what? The defined function is going to be what then? What is going to be the answer for this one, colleagues?
Minus 4 and 0.
Minus
Minus 4 and 0.
Minus 4 and 0.
4 and 0.
Very good. Then can you please do the last one of S and T of this E3? Where is the same as S dot of 0, 0, and then 1? What is going to be our answer there?
11 and minus 1.
Now you are no longer doing them. You are referring back from the previous classes, right? Thank you, colleagues. Then now, after this, we are done. Now we remember we have to represent this in a matrix form. When you represent this in a matrix form, you will have these things in terms of vectors. You write them in terms of a matrix, meaning now you are going to have what, colleagues? You can say the matrix of is either can name it with any variable that you want. Then let me say the matrix A will be equals to, you'll take the first, that one transformation of that E1, then remember it's in a vector form, then in a matrix form is going to be in a column way. You'll have 6 and minus 2. Can I get yes from you, colleagues? Do you understand? Then number 2, you take that one of E2. That's why you are going to have this minus 4 and then 0. And then the last one is going to be what? Is going to be 11 and minus 1. Is it fine, colleagues? Do you all understand, colleagues?
Yes.
Yes.
Yes, man.
Yes.
Yes.
So now you and me, last time we agreed that when you multiply, do you see that the dimension of this A is what? The dimension of A is what? Remember, the product of ST was this 3 dimension takes everything to this 2 dimension. Do you still remember this?
Yes,
This is
sir.
the product. This is the product of that.
Yes, sir.
Then and now, when you check this A, the dimension of A is what? Is 2 rows and multiplied by 3 columns. Do you see it?
Yes,
Yes,
sir.
sir.
Yes.
So now, this is what we are going to have. Then we can find the alternative method here, maybe by multiplication. We can alternative find the composition. By matrix multiplication. On the matrix multiplication, remember what we got. Before we say what we got, remember what is T. They defined that the T is X, Y, and then Z will be equals to 2X minus Y plus 3Z. And then you have minus Y plus 2Z. Do you still remember this? So I want us to apply the transformation, the basis on this. You are going to have the transformation of E1, which is the same as the transformation of 1, 0, 0. What is going to be our answer there, colleagues? Please talk to me. Or maybe I'm offline, I don't know.
2 and
2 and 0.
2 and 0.
2 and 0. And again, you have the transformation of this E2 is the same as transformation of 0, 1, 0. What is the answer there, colleagues?
Minus 1 and 1. And minus 1.
minus 1.
Minus 1 and 1 and minus 1. Which one is correct, sir?
Minus 1 and minus
Suppose you have
1.
minus 1 and minus 1. Very good. Then the last one, we have the transformation of this E3, which is the same as the transformation of 0, 0, 1. What is the answer there?
3 and 2.
Very good, ma'am. 3 and 2. Then now, the matrix, let's say now you say the matrix, let me say is the matrix B, right? Your matrix B will be equals to 2 and 0. I'm waiting. Do you understand, colleagues? And then minus 1 and minus 1. Can I get yes that everything is fine? Then you have 3 and then this 2.
Yes, sir.
Do you agree?
Yes.
Do you agree?
Yes, sir.
I don't know if you see where we are going, but since you're seeing this for the third time, let me take you back a little bit. There is something that I want to show you. Do you see where we are now? We are going to find this. Are we together?
Yes, sir.
All right. So now, that is the matrix B. Then now, for the new one, for matrix, remember you have that one of S, which is X and Y, will be equals to, that map of S is what? Is 3X plus Y. Please check if I wrote everything correct there. Minus
Yes.
X plus Y.
Minus X and
Is
plus
it
Y.
correct?
Yes.
So you do the very same thing for S of E1. But this time around, because it's in 2 dimension, meaning you are going to have S of 1, 0. What is going to be your answer there?
We'll have 3 and minus 1.
3 and minus 1. Then you have S of E2. And it's the same as S of 0, 1. What is the answer there, colleagues?
1 and 1.
The other colleagues, are you here with us? Then now the matrix representation for this one will be what? Then the matrix representation. The matrix representation is, we can name this one to be what? Is it C or what? Can I name this one to be what, colleagues?
C.
If you are saying is C, then we are going to have 3 minus 1 and 1 and 1. Is it correct?
Yes.
Is it correct, colleagues? Then what is the size of this? The size of this C, the dimension of C is, okay, fine. Let's start. The dimension of A. Where is that A? Let's go back. Not A per se. The dimension of B. Dimension of B is what? Is 2 by 3. I'm right.
Yes.
Yes, sir.
The dimension of B is 2 by 3. Even if I know you are doing second level, colleagues, there's no need to write distance like you are doing. Can I write this B as 2 by 3? And again, we write you said the second one is what? C, ne? The C is what? The C is 2 by 2. Is it fine?
Yes.
So we can easily see that if you want to multiply the 2, there is no way that you can get BC. You are going to get what? You can only get what? C. You can only get what? CB. Not BC is not possible. Do you see it?
Yes, sir.
You can easily see that the only possible matrix multiplication is C multiplied by B. Do you see it, colleagues?
Yes, sir.
It's possible, right?
Yes, sir.
Yes.
Hence, confirming that the composition that exists, we are referring to, remember the map we said as T is the one that we got that it exists. So now let's agree. You are going to get we have these things. I guess we have, please correct me if I'm wrong. You are going to have A will be equals to this C and then P. Do you all understand? I'm waiting.
Yes, sir.
So now our C is 3 minus 1, 1 and 1. And then our B is 2, 0, minus 1, minus 1, and 3, and 2. Is it correct, colleagues? Is it correct?
Yes, sir.
Yes, sir.
Yes, it's correct.
So now let's multiply. You multiply this. Sorry. When you multiply this, sorry, what's wrong with this computer now? Good. When you multiply this, you know that you are going to multiply row by column. Then you are going to say 3 multiplied by 2, the answer is 6. Then 1 plus 1 multiplied by 0, the answer is going to be plus 0 there. Then for the second entry, you are going to say 3 multiplied by negative 1, the answer is minus 3. Plus 1 multiplied by negative 1, the answer will be negative 1. Then you go to the next entry. Row number 1 will now multiply column number 3. We are going to say 3 multiplied by 3, then you get 9. Then plus 1 multiplied by 2, then you get this 2. I guess all of you colleagues, you know how to multiply. I'm simply just wasting your time. Can I get yes that you know how to multiply 2 matrices? Then for the second row multiplied by the first column, I see minus 2 plus 1 multiplied by 0 is going to be 0. Then row 2 multiplied by column 2, I see minus 1 will multiply minus 1 is going to be positive 1. And then plus 1 multiplied by negative 1, the answer will be negative 1. Then second row multiplied by the third column, I see minus 3 plus 1 multiplied by 2, then the answer is going to be plus 2. All of you agree with this, colleagues?
Yes,
Is it
sir.
correct? Then if you want, you can use your calculator there. Then in MES 2, there's no need for calculator, colleagues. Do you see that things are simple here? I see 6 minus 4, 11, minus 2, 0, and then minus 1. Can I get yes from you, colleagues?
Yes,
Can I
sir.
get yes from you, colleagues?
Yes, sir.
I
Yes,
want you to
sir.
copy this. Are you done copying? For those who are copying, are you done copying this? Are you done? I want to go upstairs.
Yes.
There is somewhere.
Yes,
Yes.
I want to go up here. This A is the one that we got here when we calculate under is the same as this. Is the same as this. Do you see it? This is what we're looking for. Do you still remember the A that you got when you come up with the new product of the new product of that map? Here it is, and it is the one that you got here. Can I get yes, colleagues? So now we can conclude that this is A. We can conclude that our product of X, Y, Z will be equals to what? Then you put your A here, which is 6 minus 2 minus 4, 0, 11 minus 1. Then you Let's agree. These two things, is it possible to multiply them? You have A that contain 2 by 3. You have variable X that contain 1 by 3. I'm lying. Is it 3 by 1? It's possible to multiply them since these two things are equal here. I'm waiting, colleagues. Can I get yes?
Yes, sir.
Yes, sir.
Yes.
What is going to be our answer? Our answer, when you multiply this, you are going to have row number 1 will multiply column. That column, you will have 6x minus 4y plus 11z. Then you are going to have what? You are going to have minus 2x and then minus z. Can you please check this? I guess this is the original transformation of t. Do you still remember? But here we wrote it in terms of what? In terms of matrices. Is it the same? Please check. Please check that transformation of t. Is it the same as this? Or maybe
Yes,
I'm
sir.
lying?
Same.
You are lying. No, this is not the same. This is the one that we got, the product of ST. The product of ST. Let me go back, colleagues, please, let me go back. I want to check something. The product of ST. The product of ST. The product of ST. This is T. Aha, this is the box. Is it not the one? This one must come, ne?
Yes, sir.
This one must be part of our test.
Yes.
Is it the one that we got down there? I'm waiting, colleagues.
Yeah, they're the same.
This star, they're the same, is the same as this. Unless if you want me to turn it to write it in this fashion of s dot of this of x, y, and then z, you are going to have what? You have it in a vector form of 6x minus 4y plus 11z, comma, you have 2x minus this z. Then here you are. Now, so this example is very interesting, colleagues. So let's see, we are left with how many minutes? 1 hour from now. It's fine. Let's check another one. You must also know about the inverse. The inverse of linear transformation. So if you did not pass that SMT H012 nicely, that part of matrices, you are going to struggle here. So now, the definition for this one, the definition, we have a linear transformation, map from T vector space V to vector space W is said to be invertible. By the way, when you see the matrix is invertible, it means that the determinant of that matrix is not equal to 0. And if it's not equal to 0, then we can find the values of those variables, and also you can find the inverse of that matrix. Then if there exists linear. If there exists linear transformation. If there exists linear transformation, now you have another map. Another map of S is the inverse of that one. Remember the inverse, now you are going to start with the vector W. Takes everything to vector space V. Such that the product of S dot this V of this vectors of vector V will be equals to this vector V and will also be equals to I multiplied by this vector V. Applies even if I have the product of T and S of this vector W, the answer will be equals to this W is the same as that identity will multiply this W. You are all aware, colleagues, that when you were multiplying from the SMTH012 and the other one of SMTB000, when you multiply a matrix, any matrix multiplied by identity, the answer is that matrix. You know that. Then now, on this one, we have our ST equals to identity operator. Last time we did the identity operator somewhere. Is it last week, I guess? In V, in vector space V, and TS is equal identity operator in vector space W. Then you must note the following. This one you know, let me just repeat, but you know, when you talk about the inverse of transformation T is denoted by T inverse. You are very quiet. Hello?
We are here, many.
Hello, sir.
We are copying.
All is well.
Well, sir.
Colleagues, all is well?
Absolutely.
Yes, sir.
Hello?
Hello, sir.
Sir.
Please talk
Hello,
to me.
sir.
Hello, sir.
Hello, sir.
Hello?
Hello.
Hello, sir.
Sir, we can
Everything
hear
is fine.
you.
Everything is fine?
Yes, sir.
Yes, we are following.
Yes.
Of T exists. It is unique. You still remember the time when you were doing the unique one solution, something like that. You know that, colleagues. So let's take this example. I guess it's the last example. Let's take this example. Colleagues, are you ready? Colleagues, are you ready?
Yes.
Yes, sir.
I wanted to hear that, colleague, so that then let's see. Find the inverse. Find the inverse of, you have this map T that takes 3 dimension to this 3 dimension. And this map defined by, let me write it with a red color, has been defined by T of X, Y, Z will be equals to, you must have 3 values on the other side, which is 2x, comma, 4x minus y, comma, 2x plus 3y minus z, close the bracket. We must find if this exists. If the inverse of this exists. If it exists. Are you ready, colleagues? Can we start?
Yes.
So we are going to follow everything that we know. Are you done copying for those who are copying? So here we don't deal with a matrix where you can check by coming up with checking if the determinant is equal to 0 or what. Here you are dealing with a map. So to find T inverse, to find the T inverse, give me a second. So colleagues, in order to find the T inverse, we must have the following. You must have your transformation of x, y, z, which will be equals to this unknown P, Q, R. You can come up with your own. And we must agree that from this, remember from high school, if I want to make x, y, z sub the formula, meaning I can multiply the whole statement by coming from left, I can introduce T inverse, where I'm going to have T inverse, but there's no need. Let me just write this and let me know if you don't understand. P, Q, R will be equals to this X, Y, Z. All of you understand this red part. You understand how I got that T inverse PQR is equals to XYZ. Colleagues, I'm waiting. Can I get yes?
Yes.
Colleagues, where are you? So now, if you agree with this, this is what you are going to have. You are going to take, let's say now, if you agree with this, I can take the original one. The original one of the T of X, Y, and then Z, which is equals to this P, Q, and then R. Then we already know they defined what is the transformation of X, Y, Z. The transformation of X, Y, Z we have it from the question is 2x minus 4x minus y, and then what? 2x plus 3y minus z, close the bracket, will be equals to this p, q, and then r. Are you there, colleagues? Do you understand? Are you still there, colleagues?
Yes, sir.
Yes, sir.
Then here on the left hand side I have 3 dimension, on the right hand side I have 3 dimension, meaning I can equate the first element on the left hand side will be equals to the first element on the right hand side. That's why I'm going to have 2x will be equals to p. Then what is x, or what is p? Okay, what is x? Your x will be equals to 1 over 2p. Do you agree?
Yes, sir.
Colleagues, then the second one, the second element will be equated to the second element on the left hand side. I have 4x minus y will be equal to this q. Then what is y? Who can tell? What is y? Do you want me to solve this, colleagues, or can we write the final answer? What is y?
Y will be 4x minus q.
Are you not lying?
No, I'm not lying.
You must write, remember you know what is x up to so far. Replace with this x by 1 over 2p. You'll get 2p
2p
minus q.
minus q.
Very good, ma'am. So the last one of z, the last one of z will be equals to, I see, is it 2x plus 3y minus z will be equals to this r. So now, what is z? You know what is x, you know what is y. Write everything in terms of p, q, r. What is z? I'm waiting, colleagues. What is that? Class rep, you are so quiet. Or maybe you are busy drafting an email to me. Class rep. Class rep, you are so quiet. Hello? Colleagues, I'm offline.
No.
No, sir, we can hear you.
We can hear you.
Okay, then let's talk. What is the answer? What is that?
7p minus 3q minus r.
7p minus 3q and then minus r. Then from here, what I want to do, let's go back now. You and me, we agreed that your T inverse of P, Q, R is equals to X, Y, Z. Can I get yes from you?
Yes.
Yes.
But now we know what is X, we know what is Y, we know what is Z. Can we please start substituting? What is X? X is 1 over 2p. What is Y? 2p minus q. What is Z? Is 7p minus 3q minus r. So we can agree that this map, this inverse, Now we can define that our T inverse of X, Y, Z, is it correct? Is going to be equals to, what, colleagues? Is it half X and then 2X minus Y and then 7X minus 3Y and minus Z? We close the bracket. Then we are done. Any question? Any question?
Yes, does this work for even higher order functions there?
Yes. Remember, we generalized when we started with this. We generalized. We said our map is starting. Is it three dimension or what? Let me see. The inverse. The inverse parts. Generally, it must work for everything. Okay. Yeah, it must work for everything. It's just because the example that we took, we simply just gave some limitation of 3 dimensions. Even if you have the n dimension, it's still going to work.
All right, thank you.
Sure. The other colleagues? The other colleagues, is there any question? No problem. If you don't have any question to ask colleagues, Mr. Class Rep, let me take this chance to say thank you for coming. Then please prepare your test is coming this week, Friday. So get prepared. During the tutorial time, please make sure that you are going to consult the things that you don't understand.
Sir, what's the scope for the test?
I guess it's everything, colleagues, that we have done after test 1. Especially the common ones, please make sure you understand them. And there are some theorems. Remember when I was teaching you, I told you that this theorem is very much important, it's interesting. Please write test 2 and exam. Those theorems are very much important. Please know them. You are going to get 1 or 2 in your test.
Please repeat what you just said.
Hey, ma'am. When I was teaching, I told you that these notes are common and these theorems are important. Some of those theorems I was saying, please write, just note on top of that test 2 or exam. Do you still remember those theorems that I was saying that? There are not many. I guess the theorems that we did, there are 3 or 4. And they are easy to understand. So colleagues, no problem. I can open my mic 1, 2, 3. Maybe it's because of network CSB. So colleagues, all is well, then we'll meet again on Wednesday. Class, please make sure that I'm going to send an email to those guys for S block. They must come and check our TB. and also the KC. Is it fine, colleagues? Bye-bye. Let me stop the recording.